Hello everyone. So from today we will start convergence and divergence of infinite series. Okay, so first of all, what is meant by series? Series is the sum of a sequence. Okay, series is nothing but it is the sum of the sequence. In the previous lecture we saw what is sequence. For example, our sequence 1, 2, 1, 2, 3, 4 up to it goes to infinity. That is called sequence. But if you add this sum, that is, if sum of sequence is carried out, then it is series. Okay, so 1 plus 2 plus 3 plus 4 is called series. Okay. Now what is finite series and what is infinite series? For example, if the sequence is given 1, minus 1 by 4, 1 by 9 and up to, then from that we get series as we have to add this all the terms of sequence, then we will get series. Okay. જ્યારે આપણે sequence ની terms ને add કરીએ તો આપણને series મળે. So here we get 1 minus 1 by 4 plus 1 by 9 minus 1 by 16 plus 1 by 25. પણ આ છે ઇન્ફાઇનાઇટ સુધી નથી જતું, આમાં આટલી જ ટર્મ્સ આપેલી છે. So such type of series are called finite series. And infinite series, here the series will go up to infinity. That is 1 by 1 square plus 1 by 2 square plus 1 by 3 square, and it will go to infinity. Then it is called as infinite series. For example, this series can be written as summation n equal to 1 to infinity 1 upon n square. Infinite series can be represented in this form. Okay. So now moving towards telescoping series. What is meant by telescoping series? A telescoping series is a series whose partial sums only have a finite number of terms after cancellation. That is, it leaves only fixed number of terms after simplification. Telescoping series means whenever you will solve any example or any question, then the terms will get cancelled and only finite term will remain at the end. Okay, telescoping series એટલે કે તમને કોઈ પણ infinite series આપેલી હોય એને તમે solve કરો તો છેલ્લે તમને finite answer મળે. તો એવી સિરીઝને કે જે ઇન્ફાઇનાઇટ આપેલી છે પણ એનો આન્સર ફાઇનાઇટ આવે છે, તો એવી સિરીઝને ટેલિસ્કોપિંગ સિરીઝ કહેવાય. ઓકે, that is, it leaves only fixed number of terms after simplification. એનો આન્સર કોઈ દિવસ ઇન્ફાઇનાઇટ નહીં આવે, ફાઇનાઇટ જ આવશે. ઓકે, અને આપેલી ટર્મ હશે એનું જે સમેશન હશે 1 to infinity હશે, પણ એનો આન્સર છે એ ફાઇનાઇટ આવતો હોય, તો such type of series are called telescoping series. So let us see the example of telescoping series. For example, એ આપેલું છે summation n equal to 1 to infinity 1 upon n into n plus 1. Then how we can solve this example? Let us solve it. 1 upon n into n plus 1 છે એને આપણે આવી રીતના લખી શકીએ a upon n plus b upon n plus 1. Okay, you know all this. Okay, you can write a upon n plus b upon n plus 1. And now from this we can find value of a and b. So how we can find? By taking LCM we can get a into n plus 1 plus bn. And now, so whenever I want to find a, I will substitute n equal to 0. So I will get a into 0 plus 1. But why we substituted 0? Because from this we get two values of n, that is n equal to minus 1 and n equal to 0. From here we will get n equal to 0 and from here we will get n equal to minus 1. So whenever I will put these values in this equation, so let us first put n equal to 0. If I put n equal to 0 in this equation, then I will get 1 is equal to a into 0 plus 1 plus b into 0. Means whole this term is 0. So from this we can get a equal to 1. Okay. So now we will substitute n equal to minus 1 in this equation 1. So we will get 1 equal to A into minus 1 plus 1 plus B into minus 1. But minus 1 plus 1 is 0, so this term is 0. So we get 1 equal to minus B, and therefore we get B equal to minus 1. So we got value of A and B. So now if we substitute this A and B in this equation, say equation 1 and this is equation 2. So if we substitute both the values in equation 1, then we can rewrite this equation as A equal to, what we got? A equal to 1 and B equal to minus 1. So if we substitute it in the equation 1, then we will get 1 upon n into n plus 1 is equal to 1 upon n minus, here we have to substitute, okay? 1 upon n plus 1 of b upon, that is b is minus 1, so we can write 1 upon n minus 1 upon n plus 1. Okay, 1 upon n minus 1 upon n plus 1. But again in the question, the summation sign is given, so we can rewrite this equation as 1 upon n into n plus 1 equal to summation n equal to 1 to infinity 1 by n minus 1 upon n plus 1. Okay? And now if we put values of n in this equation, then we will get, if first of all I will put 1, then I will get 1 by 1 minus 1 by 1 plus 1 is 2. Plus, this is the term when I put substituted n equal to 1. Now if I substitute n equal to 2, then I will get 1 by 2 minus 2 plus 1 is 3. So 1 by 3. Plus, when I substitute n equal to 3 here, that is A3. So 1 by 3 minus 1 upon 3 plus 1 is 4. And it keeps on going. Up to if I put n equal to n minus 1. And then after n minus 1 I will keep n, okay? So if I keep n minus 1, then I will get 1 upon n minus 1 minus 1 by n. Because n minus 1 plus 1 is 1 n. 1 by n, okay? And then at last I will put nth term. That is an. So 1 by n minus 1 upon n plus 1. Now see what will happen. This and here minus 1 by 2 and 1 by 2 will get cancelled. Again minus 1 by 3 and 1 by 3 will get cancelled. This 1 by n, minus 1 by n and 1 by n will get cancelled. And this 1 upon n minus 1 will get, somewhere here we will have 1 upon n minus 1. With that term it will get cancelled. 1 by 4 will also get cancelled with plus 1 by 4. So what remains here? Only 1 and this term. Minus 1 upon n plus 1. So we can rewrite this equation as limit n tends to infinity 1 minus 1 upon n plus 1. Okay? As I told you in the sequence, you have to put limit n equal to infinity to check whether what you are getting, whether you are getting finite term or infinite term. So here, if I put limit n equal to infinity here, then we will get 1 minus 1 upon infinity plus 1, and 1 upon infinity is 0, so 1 minus 0, so we got 1. That is, we got finite value. Okay? So, such type of series are called telescoping series, in which the question given was in the terms of infinite, summation n equal to 1 to infinite, but at last we got the finite answer, that is 1. So such type of series are called telescoping series. Okay? Means it leaves only fixed number of terms after simplification. So we got finite value even if the question was given in the form of infinity. So such type of series are called infinite series. Now these are some formulas which you have to remember, and it will be helpful to you when you solve examples. Okay, so first one is whenever limit n tends to infinity, x raised to n is given, and if x is less than 1, then its answer is always 0. But if x is greater than 1, then x raised to n will be infinity. Then the third one is limit n tends to infinity. If x raised to n upon n factorial is given, then its answer is 0. For example, if it is given that x raised to 5 upon 5 factorial, put limit n tends to infinity if you are asked to solve this. Then from this formula you can directly write that its answer is 0. Such type of questions can be asked in the MCQ. Then fourth one is limit n tends to infinity, log n by n is 0. Fifth one, limit n tends to infinity, n factorial raised to 1 by n is infinity. Next, limit n tends to infinity, n raised to 1 by n is equal to 1. Limit n tends to infinity, 1 plus 1 by n whole raised to n is equal to e. Such type of sum we have done in the previous lecture, and where we have substituted 1 plus 1 by n whole raised to n equal to e. If 1 minus 1 by n raised to whole raised to n is then it will be e raised to minus 1. Then eighth one, limit n tends to infinity, n factorial upon n whole raised to 1 by n, then its answer is 1 by e. Ninth one, limit n tends to infinity, n x raised to n equal to 0 if x is less than 1. And 10th one is limit n tends to infinity, n raised to n is equal to infinity. And if it is 1 upon n, then it is 0. Because if n raised to n is infinity, and if you substitute infinity here, then 1 by infinity is always 0. And the last one is limit n tends to infinity, a raised to 1 by n minus 1 upon 1 by n is given, then its answer is log a. Okay? So now again we continue with the series. Okay? What is the meaning of convergent series and divergent series? Now, as we all saw in the sequence that if we put limit n tends to infinity and we get finite and unique value, then it is convergent. And if we get infinity or minus infinity, then it is divergent. So in series also the same thing happens, that series is said to be convergent if its limit has finite and unique, and if as n tends to infinity. So whenever you get finite and unique limit, then such type of series are called convergent. Now a series is called divergent if the limit of the series is either infinity or minus infinity. Okay, whenever you put limit and if you get infinite or minus infinite, then such type of series are called divergent. And oscillatory series, and here the limit of series will not be unique or finite or infinite, but here series will oscillate. For example, if we saw this in the sequence also, that if it is given 1 minus 1 plus 1 minus 1 up to, then we have more than one values for n equal to odd. If n is odd, that is first three terms આપણે લઈએ તો -1 ને 1 કટ થઈ જાય તો 1 આવે, એટલે odd terms હશે up to infinity, તો answer will always be 1. પણ n even હશે તો બધી ટર્મ્સ છે એ કેન્સલ થઈ જશે, તો આન્સર છે એ 0 આવશે. ઇટ મીન્સ કે 1 અને 0 કોઈ ફિક્સ વેલ્યુ નથી આવતી, પણ 1 થી વધુ વેલ્યુ આવે છે, એટલે 1 અને 0 આવે છે. તો such type of series is called finitely oscillating series. કેમ કે એની વેલ્યુ ફાઇનાઇટ આવે છે પણ એ ઓસિલેટ થાય છે, 1 આવે 0 આવે. So such type of series are called oscillatory series. So now let us move towards the examples of series, and we will examine the nature of the following series. Okay? So now from this we can write that our series Sn is equal to 1 square plus 2 square plus 3 square plus 4 square up to it goes to infinity. But summation of n square terms is always equivalent to it is a n square series. We can directly write that n by 6 into n plus 1 into 2n plus 1. Okay, summation of n square series is directly given by this formula. And now if we put limit n tends to infinity in this term, that is n by 6 into n plus 1 into 2n plus 1, then we get, if we substitute here, then here only infinity into infinity plus 1 is always infinity. Okay, so we got answer of this question as infinity, and as we got infinite, we can say that if the series is, if you put limit and if the answer of the series is infinite or minus infinite, then answer is divergent. So after putting limit, as we got infinite, answer of this question is divergent. Okay, so example 2. Log 2 plus log 3 by 2 plus log 4 by 3 plus up to it goes to infinity. So we can rewrite this equation as Sn equal to log 2 plus log 3 by 2 plus log 4 by 3 plus up to. From this we can say that the order of the series is in the form log n plus 1 upon n. કેમ કે જ્યારે આપણે આમાં n1 મૂકશું ત્યારે આપણને log 2 મળશે. n equal to 2 મૂકશું ત્યારે log 3 by 2 મળશે. n equal to 3 મૂકીએ તો log 4 by 3 મળે, and up to it goes. So from this we can say that the format of this matrix is log n plus 1 by n. Okay, so we can rewrite this as, if we take log common, then we will get 2 into 3 by 2 plus, if I take log common, then this all the terms will be in the multiplication, 2 into 3 by 2 into 4 by 3, and at last that is n plus 1 by n. Now this 2 and this 2 will get cancelled, this 3 and this 3 will get cancelled, this 4 will also get cancelled with the next term. And again this n and this n will also get cancelled. So what we will get? Log n plus 1. And now if I substitute limit in this equation, then we will get limit n tends to infinity log n plus 1. And if I put infinity here, then we will get log infinity plus 1, and log infinity is always infinity. Okay, and as we got the answer infinity after putting the limit, so we can say that the given question is, given series is divergent. Okay, so next example, example 3. 1 cube plus 2 cube plus 3 cube plus 4 cube up to, it keeps on going up to infinity. Then from this we can say that if the terms given are in the summation n cube, and the formula of summation n cube is n into n plus 1 upon 2 whole square. Okay, so and it is similar to n square, કે n square માં જે ફોર્મ્યુલા હતી એવી રીતના આમાં summation of n square ની એવી રીતના summation of n cube ની ફોર્મ્યુલા મૂકશું અને ડાયરેક્ટલી પછી એમાં આપણે લિમિટ સબસ્ટિટ્યુટ કરશું. So we will get limit n tends to infinity n into n plus 1 by 2 no whole square, and if I substitute in here, then this whole term will be infinite, and as the answer is infinite, we can say that the given series is divergent. Okay, so now moving towards example 4. Example 4. summation n equal to 1 to infinity under root n plus 1 minus under root n is given. So here as the summation is given, that is 1 to infinity આપેલું છે. So we can directly substitute values in this equation. So if we put 1, then we will get series Fn equal to 1 plus 1, that is under root 2 minus under root 1 plus, if I put 2, then 2 plus 1 is under root 3 minus under root 2. This is A1 term, that is when I put n equal to 1. This is A2 term, that is when I put n equal to 2. Now A3, that is when I put n equal to 3, then I will get under root 4 minus under root 3. Plus up to, it will keep on going. And in the second last term, if I put an minus 1, then here I will get under root n minus under root n minus 1. And the last term, that is if I put a nth term, then it will be n plus 1 minus under root n. But now you can see that this minus root 2 and this root 2 will get cancelled. This root 3 and this root 3 will get cancelled. Again this root 4 and here somewhere minus root 4 will be there, that will get cancelled. This root n and this root n will get cancelled. This root n minus 1 will get cancelled here. So only this under root 1 and this under root n plus 1 will remain. So we can write it minus under root 1 plus under root n plus 1. And if I put limit here, that is limit n tends to infinity of Sn, then what is our Sn? That is minus under root 1 plus under root n plus 1. So if I substitute limit n equal to infinity here, then I will get minus under root 1 plus infinity plus 1, that is infinite. And infinite plus anything, plus or minus, adding anything or subtracting anything from infinite is always infinite. So again I got infinite here, and as we got infinite, we can say that the given equation or given series is divergent. Okay? So just by substituting the limit, you can decide whether the series is divergent or convergent. So thank you everyone. I hope you all liked my video lecture. Do practice such type of examples at your home. Okay? Thank you.